Number 4, we've got this floodgate that's in a dam, and it's in the shape of this triangle, and it's got water up here at about 8 feet. And we want to know the hydrostatic force acting upon the dam. So all of this underneath that blue line is what the force is acting on, as the water is acting upon. And so what we do is we need to put the origin somewhere. I'm going to go ahead and put it down here at the bottom of that floodgate. So that'll be 0. This will be the top of the dam, that's 10. And this is at 8, which is where the water is. And so I know that to find that force, it's the integral rho g, which is 62.5. And then I know it's equal to the depth of a strip. And so what I'm doing is I'm going to put a strip across this thing, and I'm going to find the force on that strip, and then the integral is going to add up all those over the extent of where the water is. So I need the depth times the length across that strip, because that'll give me, with the dx, will give me the area of that strip, and so this all put together will give me the force. Well, so some things I can put in already. For example, I'm going to be adding those strips up based on where I put my origin from 0 to 8. The depth, if this is happening at x, then this is 8 minus x down to where that strip is, so this will turn into 8 minus x here. And so all I need to find is the length across there. We'll just call it L for length. That's what I need, is the length across there. And it does vary depending on how big the x is. So, but I can see from what I have here, I've got similar triangles. Let me just draw them again, since I've got so much on that already. But so I've got my strip across somewhere here, and there's an x here. And so this is 5, this is 10 all the way to the top, and this is the unknown right here, L. And so I can use similar triangles. I know that L over 5 would have to be the same as, so I'm using this little triangle to when I say it's similar triangle, so it's this little one here and this big one here. So this L over this 5 would be the same as this side over 10. And that side, well, since this is x to here, this would be 10 minus x to there, because it would be 10 all the way to the top. So that gives me that L is equal to 5 times that, and then the 5 will cancel out, so I get 1/2 10 minus x. And I'll put that there. So I get that the force is equal to the integral from 0 to 8, 62.5, 8 minus x, 1/2 10 minus x. And that's all I was asked to do, is set it up. Next one says find the arc length of this curve on the interval 0 to power of 4, and we can stop after we've gotten to the point where the integrand no longer contains a square root. So we don't have to work it all the way out, but we do have to do a little bit of work. So we know that that length is given by the integral. Well, the integral is given to me 0 to power of 4 of the square root 1 plus the derivative of natural log of cosine. So let's go ahead and do that. Is the derivative, when you do the chain rule for natural log, is the derivative of what's inside. Well, the derivative of cosine is minus sine divided by what's inside, which is cosine. And then we square that from the formula for the arc length. So there's the setup. And then I have a little bit of work to do to figure out how to get rid of that square root. So let's see, that's 0 to power over 4. Sine over cosine is tangent. So what I really have here is just tangent squared. And if you look at that carefully, you should recognize that's an identity. 1 plus tangent squared is secant squared. So this is 0 to power over 4 square root secant squared. And now it's gone, because square root of the secant squared is just secant. And this isn't too much more to do if you wanted to finish it, because remember, the antiderivative of secant is natural log secant plus tangent, but then you got to plug in 0 and power 4. So let's just stop there, because that's all we're supposed to do, is get rid of the square root. But we can see how to finish if we wanted to finish it. So that would give me the arc length if I would carry that out.